dragged in. I just happened to be flipping through Craigslist and somebody was giving away this Teac portable DAT machine. But when I got it, it has this sticky, like the plastic is decomposed. And before I look at it's just leaving this black shit all over my hands, right? This is from the plastic material. The plastic is actually decomposing. Before I actually get into this thing and do any work on it, and see if I don't even know if it works at this point. It'd be great if it does, and that's going to be the project, just to get this thing going if it isn't. But I got to get this sticky crap off here. What this is from ultraviolet light causing the plastic to decompose. And the best way to get this crap off, I'm just showing you this now on the camera. I'm going to put the camera away until I've cleaned this up because I don't want to get my camera all marked up with this crap. But the best way to get this off is just to use some isopropyl alcohol, pour it on a cloth, you know, and then just rub it like crazy and it will come off. This stuff will actually clean up quite nicely. So before I even get into this thing, I just want to show you how you can clean up if you've got a rubberized coating on plastic. And that's what this was. This was like a rubberized coating on the plastic to give it that texture, so it didn't feel like cheap plastic. Well, the problem is the stuff deteriorates after a while, and this will actually should clean up quite nicely when I'm done here. And once I get this thing cleaned up, then we'll work on it. But I just wanted to show you guys how to go about cleaning this thing up before we even get into this. There we go, much better. No longer is it sticky. It's clean. You know, all that sticky, gummy, black crap that's all over my hands now and all over the rags here. It's been removed. I just used good old 99% isopropyl alcohol to clean it. Now we can look at this thing and see if it even works. But before I do that, I have to find a way of powering it up. And Teacs were kind of unique. And if you think Sony had some strange voltages for some of their devices, like 10.6 volts for their portable, I think that was the DAT machine that used that. Let's see here, what is it? Got the old one still here. Yeah, 10.5 volts, okay? You think Sony was bad for oddball voltages. Well, the Teac is just as bad, if not worse. Check this out. DCN. It's a split supply, -7 and +7 volts with respect to ground. And it even has a ground. And, okay, what about the battery? What about the battery? The battery is a split voltage, 6 volts, positive 1000 milliamp hour, 6 volt, negative 600 milliamp hour battery. Talk about an oddball combination. Anyway, I gotta find a way of powering this thing up and then we can test it. Okay, so basically what I've done is I've made myself a split voltage power supply by just using a couple of AC adapters and put the positive of one adapter and the negative of another together. That forms my common ground, and they're 7.5 volt adapters, so I've got plus 7.5 volts here, negative 7.5 volts on the other terminal, and we just connected it into the battery terminals on the back, appropriately marked by looking at the terminals on the bottom of the battery, which were marked ground. Where are we here? Ground, positive and negative. The battery goes in like that. So the ground is here, and the positive and the negative, which I've connected. Ground, which was green, positive, which was a yellow, and the negative, which was black. Now, if this thing was working, I would expect it to turn on. But as you can see, it's dead. So this unit don't work. That's perfect. Let's tear it down and see why it doesn't work. So we have a few screws in the bottom and around the edges here to remove. We'll remove all of these screws and then hopefully the bottom cover will lift off without any trouble. I've never opened one of these units before. In fact, I've never seen one of these units before. The only portable DAT that I've worked on is the TCD. I think it's the TCD3 that I have. And it was a consumer model. This one here, being a professional model, it's got the XLR connectors and everything on it. So this is a few levels higher than what I had, but internally they should be quite similar. They're both going to have a rotating head drum because it's a DAT format, but I believe the Teacs use a full-size drum like the studio decks did, as opposed to Sony, which crammed in the much smaller drum and wrapped the tape 180 degrees as opposed to 90 degrees for the full-size drum. So this one should be a little bit easier to work on mechanism-wise, just because things aren't quite as small. After removing all the screws, the bottom cover just lifts off, just like that. And we see a circuit board that's completely shielded. And see if the top cover will lift off this thing too. Got one more screw here maybe. And a couple more screws down through here, and this should lift. The front top cover should come off for remove these remaining screws. There's one there. Just have to work the cassette lid, because when the door doesn't open, the door is a little larger, or the door is a little smaller than larger than the opening, so that's going to prevent the cover from coming off. Maybe not. Okay, now the lid's open. Let's see if I can take that off. Here we go. Pull that forward. Now we lift the top off, and here we see a full-size drum, right? And it rotates free, so there's no problem with that. But the unit itself is not turning on. Okay, so I'm just going to reconnect the power to it again. One thing I did notice is that the eject button on the top was sticking, and it may have had the switch closed, and that may have been why the unit wouldn't turn on. So now that this button is free, let's see if it'll turn on. Nope, still no power. Okay, let's check and see whether there's a blown fuse or something. Looky over here. This is where there's a couple of resistors that are on there, and they look like they've gotten pretty hot. These solder connections right here, like these, there's a couple of resistors, and these look like they're fusible resistors. They're connected to the switch and the battery switch. We've also got the external power input here. I might even try just soldering my adapter wires right down to this and see whether I can run it directly. I don't have this plug, but I can solder down directly. So I'm going to try just hooking my ground and my positive and negative wires up to here and see whether it'll turn on directly without going through the battery terminals. So as you can see, I've connected my power supply here. We'll test it now and see whether it does any difference. I don't think it's going to make any difference, but we'll just test it just to make sure. And it still doesn't turn on. So now I'm going to peel back the shield here and take a look under the board. And I'm not too worried about the plug on this thing. If I get this unit working, I'm not going to be ever using it as a portable machine. I have no need for a portable DAT, but it would be nice to have another DAT, just one that works. So I will build a proper power supply. I'm just using a couple of AC adapters now just to see if it will work and if I can get it working. Once I get it working, I'll go and get a proper transformer with a center tap and build a couple bridge rectifiers and use a couple of regulator ICs to set the voltage correctly. So this is just a temporary thing just to see if I can get it working. Okay, I just found out something I did not know on this unit because I've never taken one of these apart before, but there's actually a circuit board in the front here that plugs in with a couple of plugs into the main board. And by loosening up the front, those plugs come undone. So I've just reseated those connectors. So let's just see whether this unit will turn on now. Oh, aha. I get life. I get life out of this thing. Well, there's... Holy smoke, it opens. Do we try this thing and see if it works? I think we do. I've got it plugged into my amplifier now. I've got my tape labeled Classic Rock. Oh, that's not good. That's definitely not good. We have a servo problem on this thing. What do you bet? It's going to be some capacitors. I bet you we've got some of those surface mounted piece of crap electrolytic capacitors on this thing that are, yeah, the tape almost goes into fast forward. The drum is just barely turning. The drum's actually not turning. It's the tape itself that's pulling the drum. It rewinds. So let's eject this tape. At least we know that some of the motors turn. Now I know where I have to look. It's going to be capacitors. Let's take the board out and see what we need to fix this thing. Right here I can see a couple little capacitors right on this board here that are ugly. They've just taken some regular capacitors and they've mounted them in a little case and bent the leads over, but those have got to be replaced. I see a few of those that are obviously leaking. I'm just going to get the board out and we'll take a look and see what's underneath here. I imagine it's going to be some of those ugly surface mounted caps that's in this thing. I'll just unsolder the shield wires here and we'll just pull the face off. As you can see, there's the plugs that I was telling you about that weren't connected to the board. That's why it wouldn't turn on. And now I should be able to just remove a couple more screws here and lift this whole board out and see what's under there as far as surface mounted ugly electrolytics go. So let's undo a couple screws here. I'm just going to unsolder the shield. It's soldered right down here, and then we can remove the shield, and it's also soldered over here on the edge. There we go, shield is out of the way now. Now we can see the board. And I don't see any surface mount caps on this side of the board. They're all going to be on the other side. So let's just undo a couple screws here so we can flip the board over. And hopefully this will flip over nice and easy and I won't have to worry about taking off a bunch of connectors. I'll have to undo a few of them here, but hopefully this isn't going to be too big a job to get at. We'll just undo the 3 battery terminals. Fortunately, they're different lengths, so it's easy to figure out which one's which. We should free up the board enough that I should be able to tip it up. Maybe undo a couple more of these connectors here. Okay, and I think we also have to take out the balanced input board, because if I'm looking at this right, it plugs in to the other board. So with this one plugged in, it's not going to release the other side. I think this has to come out first. Maybe just that one has to come out. I have to release these plugs. Okay, this board is released now. I wonder if it'll come out. Well, there's our board, and it does have a few of those ugly surface mounted caps. We've got a couple of them here that are going to be bad. It also has conventional ones. These aren't surface mounted, they're conventional, but they're turned on their side. I don't know if these ones are bad or not. I'm going to take the ESR meter through and we'll just look at which ones are bad in here, but I think for sure we're going to find that these little bastards here are probably the cause of our problems. This is our motor drive servo circuit. According to the bottom of it here, it says motor drive block, which is right there, which is this area here. This was kind of a pain in the butt to remove this thing. I had to take all these other circuit boards out, including the little preamp board, which is over here on this side somewhere. The one that had a couple leaking caps that you could see. That one is hanging over here. I think that's the preamp. Anyway, that had to come off too. this one way over here. So not as big a mess as a Sony portable DAT to tear down, but still a fairly involved one. Let's just check the capacitors out and see how they look. But I think for sure that these ones here are going to be bad, because these surface mounted electrolytics, they're bad news. Whenever you see those things, they got to go. So I'll just show the measurement of a few of these capacitors with the ESR meter. Every one of these caps is bad. Okay, like this is a 47 at 6.3 volts. It's measuring open, right? There's a shorting the probes. It's open. Here's another one. It's open. Another one. Every single one of these is, I found a few that actually get a reading at all, like 20 ohms. Yeah, okay, that's bad. It's supposed to be a 10 microfarad at 16 volts. Here's another 10 at 16, it's open. Every single one of these capacitors needs to be replaced. So what I'm going to do is I'm going to head down on Monday. I'll take an inventory of what capacitors I need for this, and I'm going to go down and I'm going to pick up all new capacitors. We're going to recap this board and fix this Teac DAT machine, and then I can add another DAT machine to my collection. So I'm going to start out, I've got some new capacitors. I'm going to start out by replacing these two 33 10 volts. I don't have surface mount ones. That one tests good and that one tests good. These two here are bad. So I'm going to change those two. I don't have a lot of room to work on this, so I'm not going to change this third one over here because it's testing good at this point. I don't have a lot of room to work on this thing, and I have to lay these things on the side, so I try and change as few of it as possible. All these other ones do have to be changed out though, so we'll take out the ones that are definitely testing bad and swap them out. Just remove them in the normal manner, cut them off, and then remove the pins. As you can see, I got a new tip for my soldering iron. Okay, now I'm going to change these 10 microfarad caps that are right there in the middle of the board. Let me just see if I can focus this up a little sharper for you. So these three here, these 10s are going to get changed out now. And these are just conventional capacitors that have been laid on their side. So they did something right for a change, right? So I can just heat the leads up and lift these ones right out. And of course, any of the circuit glue that they use to secure these things down needs to be cleared off the board, because this stuff here goes corrosive and it actually could eat the traces away underneath it. So this stuff here has to be cleared off the board. That's that, it was at one point in time yellow circuit glue. and this stuff is this terrible stuff that goes wherever here. Let's see if I can get this a little sharper for you guys. So this circuit glue here, this stuff goes corrosive, and it actually can eat the copper traces underneath it. So we're gonna have to scrape this off and just make sure that our traces aren't damaged underneath here. So we just bend the leads, making sure our polarity is correct. We just tack down the leads and make sure the capacitor lies flush. We'll do the same for the remaining caps on the board here. Over here I have 3 more 10 microfarad caps to change. So like the other, actually I have 4 more of them. I have one up here as well. 10 and 3 more here, so I'm going to change these 4. And like the last one I did, I just doing them all in doing the same sizes at once. And we know they're bad because they're not that they're leaking, because they're not actually leaking anything on the board onto the board, but just the fact that I've tested them all and they're all bad. Just a bad design, these type of caps. So we'll clean up the board here, clean off this glue that they put on there, and install our new caps. And I think that once we've replaced all these capacitors on this board, and this is made by Matsushita, there's their Matsushita logo. So this is a Teac, and what a lot of people didn't realize was Teac was actually a subsidiary of Panasonic. So a lot of the Teac stuff was made by Matsushita Electric. And Tascam was Teac's professional. That was their studio units. But anyway, this one's a Teac, this DAT, and it's essentially a Panasonic mechanism, and it's a Panasonic board. There's the Matsushita, or Matsushita, however you want to pronounce it. That's their logo. So we're going to continue replacing these 10 microfarad caps. Once I get this board populated, we'll see if this thing works. One thing I've noticed is a lot of people tend to ask me questions about electronics, and I'm usually quite happy to answer questions when I receive them. Keep in mind, I receive on an average over 100 emails every day. Not everybody asks questions in the forums, but I receive tons and tons of email every day at my email addresses. And I don't do this work for a living anymore. This is more of a hobby for me now. If I know the answer to your question, I'll answer it. And I do read every message. But don't be upset if you don't hear back from me right away, because I do have other things away from the YouTube channel. And again, if I know the answer to your question, I'll answer it. But if I don't know the answer to your question, then I'm not going to respond. I've had a few people that have sent me multiple messages, and one guy, or one, I don't know if it's a guy or not, but one person over the course of, I guess it was 2 days, sent me about 30 messages, and in broken English. And some of the messages was, why do you not respond? Well, I don't respond because I have a life away from the internet. And 2, I'm not familiar with a product for a different market. So I didn't know the answer to his question, but for 1, but 2, getting 5 messages over the span of 15 minutes from one person, it's not going to draw a faster response. If you ask me a question and I know the answer to it, I'll respond to it when I get a chance. The thing is, I'll respond when I get a chance. And that's not all the time. My regular full-time job takes priority to the hobby projects, which is what this is. So on my regular job, a lot of times I'm not able to respond, if you get my drift. Okay, we'll remove the 22 microfarad caps this time. I think that's it. There's only the two of them there, and there's a couple more on this board here. Change these three here on this board. Do these two on this main big board first. We're running out of space here. These caps are a little bit taller than the ones that came out. So hopefully I'll have enough room that I can get the board back in place when I'm done here, because I am kind of crammed for space, and this being a portable unit, I don't have a lot of room to work on this thing. But hopefully everything will be low enough profile that it'll go back together. Somebody started up something that's relatively noisy. That was a relatively noisy diesel car. Now the choking fumes will waft my way. Just gonna clean off the traces here and see if there's any damage to them from this glue that they used to hold these parts. I can't understand why they use these parts. This is probably made in the era of time where the surface mounted ones were failing, so they figured they would go to this design, which is a conventional capacitor, and just make it into a little surface mount by bending over the leads. I'm sure that was the idea, right? Was that the surface mounted ones were so bad and failing at such a high rate that this was the attempt at salvation for surface mounted devices. Was they were going to try and make electrolytics this way, and well, they didn't last either. So now I'll do the 47. So there's 3 of them here, 1, 2, and 3. And then the only ones that are left are the 1 microfarads. And then I can start assembling this thing again. Well, that's it. I've got all the caps that I'm going to change replaced. I didn't change these 3 because these 3 measured good, and I didn't have the exact value for them. So due to size limitations, I didn't have ones that I could actually get in here, but I did measure them with the ESR meter, and these 3 are actually fine. But all the rest of the ones that tested bad have all been replaced. So now it's time just to get the board back in and connect everything up and see if I've created a working DAT machine. So as the unit continues to go back together, I'm just going to pop in the head preamp now, secure it in place with its grounding screw over here. Preamp is back in place. I've got the front cover snapped on, the circuit board's mounted in place. It looks like all of the capacitors are going to clear. So now it's just a matter of reconnecting the connectors for the various other boards in the motor. So plug those 2 in there. I've got 2 more plugs on the back here to plug in. I don't need to worry about these right now. These are the battery terminals. I'm not too worried about them because the unit's not going to be running on battery anyway anytime soon, if ever. I just want to see if it works. So reconnect this is the capstan motor ribbon cable here. Reconnect that. So while I'm checking this thing out, I went to turn the capstan motor by hand and it appears to be sticking, so one of my capacitors on the bottom must be pushing up against the capstan motor or one of the belt, the drive belt. So I'm going to take the thing apart again and just see if one of them is sitting a little too high, but it looks like we may have a bit of a clearance issue on this thing, which is what I was afraid of when going to regular capacitors from surface mount, and you don't have quite enough clearance in there, but we'll see if we can make it work. I'll just take it apart again and see if I can get a little more clearance and maybe relocate some of the parts a bit. So what the heck, I'm just going to pry the board down a bit with my fingernail and see whether it will play. And let's see here, a load of tape in here. Okay, there it's going. Are we going to get any sound? Are we going to get any sound out of the speakers? Aha! See? If I let go of the board, getting a few errors here, but it's working. Just gonna pull that thing apart again and see if I can get that sticking capacitor, the capstan motor free. So all I do is I just loosen off the board a little bit here, and you can hear I don't want to be playing too long in the background here, but I still got to take the board out and lie a cap over or two. If I push up on the board, it'll stop. So we just have a bit of a contact problem here. Just wanted to prove that it actually will work, and then I'll pull it apart again. There's rewind. And then we'll eject the tape. And then I'll just open this thing up again and see if we can free up what's causing our capstan motor to stick. Looking at it, it might have been this capacitor here. I had this one bent the other way in here, so I've just turned it around. It might have been this one that was making contact with my capstan motor. Something was either touching the pulley or the capstan motor and causing it to jam. So I'm just going to give this thing a good close inspection and see if I can fit it together without anything touching, and then we'll give it another go. But we know we're close because it's playing back. It's not playing back perfect, but we're working on it. It's doing better than it was when I got it, that's for sure. And if you remember when I got it, it was completely dead. Okay, the unit's back together. Let's test it. Got power. Check button. Load the tape. Tape is threading. And play. Gonna mess your mind and say. I have to check the alignment on this, but hey, it's playing now. Wonder why that drum wasn't starting up there initially. Anyway, I'm going to check this out some more and see what's going on. We'll put the scope on there and check the alignment and so forth. But it is Other than some noise in there, we'll scope that and take a look at the RF. But hey, we're making progress. So we're just going to put the scope on here and just tweak the guides a little bit to try and bring this. So I'm just putting it on the EQ point here. I don't know how that scope's going to show up on this rolling shutter camera, but anyway, our RF is bouncing around here a bit. It's going to try and flatten that off a bit just by making some slight adjustments to the guides. And still getting the odd error. I'm gonna let it play here, but it almost sounds like something might be in the gears too. I can hear something ticking every so often. So I'm just gonna let this thing play for a bit and play around with it, and we'll keep you informed as to what I find. So let's shut the camera off for a bit while I work on this. I know what's causing my problem with my servo going out of lock a bit. Over voltaging. This unit is designed for a plus and minus 7 volt split. So it requires a split power supply, plus 7 and minus 7 volts. Remember, I haven't built the right power supply yet. I'm just using a couple of unregulated adapters. And I find that I've actually got plus 10 and minus 11.3, which is causing my motor drive ICs to get hot. So I'm just queuing up a track here, and it should play. As you can hear, the unit is playing. We don't have any errors in it now, and I don't want to leave it play too long here, as I say. And there we go. It's working. I hope you enjoyed this video. As I say, I'm going to shut this thing off now because I really don't want to burn this thing out, and running at 3 volts over its rated voltage is just asking to make something go pop, if you know what I mean. I'll catch you in the next video. Bye.